Hi, everyone. I'm Sam Armani, SVP Business Development at Mimik. It's a pleasure to be here with you today. In my presentation, as Satish explained, I'm going to go over how we can transition from central cloud to hybrid edge cloud, which is something that we at Mimik have been working on for the past decade and is now available to developers and enterprises to use. So to start, let's look at the current status of data connectivity and processing that is happening. So today, the way all the applications are in various sectors, obviously banking and fintech, all these devices that are, we call them edge devices that are running applications and are processing data, generating data. Majority of that data is going through a combination of public and private cloud for it to get stored, processed, and streamed and accessed amongst various devices and systems on the edge. And then with the increasing amount of data getting generated from these applications that are running on the edge, there is an increasing demand for high bandwidth, heavy compute power by adding servers in the data centers. Now, there are some challenges that we're facing as a result of today's centralized model. One is latency in communication because everything needs to go through a central data center or cloud and then come back down, even if the devices are in the same proximity from one another. There are issues around data privacy, and that obviously is a big one and important one when it comes to the world of fintech and banking. And that's a big one. And the reason for it is today, again, all of your data needs to go through a third party server and everything needs to go there and gets copied in order for any decisions with that data to be made. And then the other one is the cost that is associated with that. Again, the way things work today, all of the data gets uploaded to the cloud in a raw, unstructured format, and then it gets converted from unstructured to structured in the cloud. And then what's needed to go to other systems will go to the other systems, but all the data remains on the cloud. And based on standard industry data, it shows that around 75% of that data, in fact, will never get used, which is dark data. But there is a heavy cost of maintenance associated with that, which is something that is a problem that today all enterprises are dealing with. Then there's the data security problem because more data in motion, more vulnerability to security hacks. There is the energy element because any service that you launch, you need to add servers to support it. And there is a heavy cost of energy associated with it. And then there's a cost of course, hardware, bandwidth, and hosting. So all in all is an expensive solution if we're looking to scale from where we are to support the future applications. Now, let's look at the evolution of these edge devices. And again, when I say edge device, I'm referring to all the end nodes that are generating or the data source. So you can think of ATM machine, you can think of the all the systems in the bank in this scenario that from the desktop, mobile devices, tablets, that the data source basically is. Now, when you're looking at these devices, you see that year over year, these devices are becoming more and more powerful in terms of the compute power, memory, which is memory storage processing. Just for the example, if you take an iPhone 13 or Samsung Galaxy phone today, it has more compute power than a server room had just a few years ago. It's pretty much a server in your hand. And then when we're looking at the IoT devices or headless devices, we see exact same trend that these devices are becoming more powerful in terms of their capability year over year. So all in all, we see that these devices are becoming more powerful. Now, let's look at the evolution of the applications that are running on these devices. Um, oh, I think I just noticed that my slides are not changing. I'm sorry about that. So now I'm going to the next slide. Okay. So when we're looking at the evolution of the applications on these devices, you see that the way things work on the far top left side, in the old days, or the so-called legacy applications, on the front end, this is just a mobile as an example, but again, can be any type of device. You had a thin client running, and then there was this monolith backend, which is the entire business logic behind the application that is running somewhere in the cloud. Now, from there today, with the modern applications, the way things work is that um, uh, still you have a light agent running on these front end devices. But the backend is now decomposed of microservices and an API gateway. So from monolith, now it's in the form of microservice architecture. So even though these devices have become more powerful, we're still not doing anything here, but the backend has evolved. Now, what Mimik is enabling, which is on the right side here, is a more balanced approach of distributing the microservices, not only just on the cloud. We're now enabling to put them on the front end devices, the end nodes, and on the back end or anywhere in between. So basically, using Mimik platform now, whoever is developing the services can decide what functions in form of microservices will run on the front end devices as part of the apps, and what would run in the back end or anywhere in between if you have other hardware available. So this way you get to fully distribute the workload across all the hardware that is available to you, and you'd be able to address some of the issues that I just mentioned. So with this way, you're moving from the fully centralized model, which is the left side, to a hybrid edge cloud model, where every device on the edge acts like a micro cloud server, can run some of the functions locally, and yet go to the cloud for things like global functions, so wherever it makes sense. And as a result of this, we're also enabling a concept called service mesh, which is now devices can communicate in a peer-to-peer fashion at the application level and microservice level, and yet go to the cloud when necessary. So by doing this, you'd be able to achieve a much cheaper, faster, resilient, private, and green solution with less data transfer to the cloud. Now, what are the benefits? This is very much correlates to the first slide I showed. By architecting your application this way, you'd be able to reduce your cost of cloud hosting by up to 90%, depending on how much of the logic you put on the front end applications. You'd achieve optimal latency, because now not everything needs to go through the central cloud, and some of the functions run locally right on the device, which you would have minimal latency. And then when there are multiple devices and systems involved, again, in many scenarios now, the devices can talk to each other in a peer-to-peer fashion, hence less latency in communication. We enable 100% GDPR compliance by function. So this is privacy by function, meaning that now the developer can decide when they're architecting the application that what data goes to the cloud, what data remains on the device. And for the data that remains on the device, they get to decide how it's going to be accessed by other devices and in what form and fashion. So in other words, we're enabling that full control over data privacy, and bringing it back to the hands of enterprises who are developing the services and apps and developers. We're enabling military grade security as part of our platform, which is six layers of security built into the front end core of our platform. And of course, the developer can add more security levels on top of that as needed. We are enabling optimal system resiliency. And by that, what we mean is that, for instance, in a hyper-local environment, if you lose your connectivity to internet for a period of time, your systems continue to work and communicate until you regain your connection back. Where in today's model, that's not possible. The whole system will go down. We're reducing the data transfer and lowering carbon emission footprint as a result of that. So, all in all, we're enabling a much greener solution. Now, the question is, do I need to change my infrastructure and tool sets in order to use the Mimic platform? The answer is no. And that's part of the beauty of our solution. Basically, our technology works on pretty much any operating system. We work with any cloud backend deployment. We work with any communication system. So devices can be, some of them can be connected to LTE, some of them can be connected to Wi-Fi. And our technology can be used on any type of device and hardware. So we're agnostic to all of that. So we give that complete freedom to the developers to develop their application in however way they want. And another part that is important is that now, for instance, some of the a lot of systems in the commercial banking is web-based, and one of the reasons for adoption of web-based in general is the fact that you develop it once and it works on any device. Now, using our platform is pretty much the same way, because you develop your edge microservices once for one platform and you reuse it all across. So in other way, now you can have the optimal solution, which is a native application to any device, and yet your development can be very fast with a much lower cost of maintenance and cost of development. And for enterprises, aside from lower cost, development costs, they're now be able to avoid vendor lock-in issues. So at any moment, they can decide to switch their vendors, and their architecture and solution is not going to fall apart. It is still stays there and works. And also, we're enabling them to accelerate innovation by now being able to have this peer-to-peer capability amongst different systems. And also, we're enabling interoperability, where now data can flow across different systems, and you won't be tied to one system or one ecosystem for things to work. Now, the next thing, so what does the solution really contains? The way things work is that any developer sitting in the enterprise can go to our developer portal and download our core platform, which is Edge Engine, which is for whatever operating system that they're developing on. And there is the Edge SDK, which is a lighter version of that for FreeRTOS microcontroller. Then they would develop their Edge microservices. We have a suite of Edge microservices that we also make it available to the developers. Once it's finished, they publish the application. And then, of course, there are some hybrid Edge optimized app domains, software as a service components like identity management or Edge-based microservices that we also make it available to our customers. And then some business intelligence, such as analytics. Again, let's say if you want to develop, start developing using Mimic today, there's really nothing new as a developer that you need to learn. If you're already familiar with the serverless microservice development, that is something that is happening on the cloud. Now you'd be exactly doing that on the front end application side as well, using whatever tool that you want to use. You can develop using whatever native programming language that you want to use for the OS of your choice, and you can develop your edge microservices in whatever language as well. You can use RESTful APIs. So all in all, you have a freedom of choosing what operating system, what programming language, and once you develop on one platform, you can reuse a lot of that code for developing on other platforms. So that makes your development life cycle much shorter, and the cost would be much cheaper. Um, Now, these are some of the scenarios. It's not everything, just for example, as a reference, I've put this here. So on the left-hand side is a scenario where you have multiple clouds involved in a transaction. So you have a device on the front end that now, but there are the app intelligence reside on two different clouds. Now, today, all of the data from the front end app that gets generated has to travel to one cloud and then communicate to the other cloud for things to basically work depending on what the use case is. Now with Mimic, right on the device, front end device side, you can the data gets converted from unstructured to structured, and only the data that needs to the whichever cloud, it goes to that cloud directly. So you select the anonymous data that goes to the second backend, and instead of that goes to first backend. So this way you're not uploading everything, and it's a much more secure private solution, and it's more cheaper with data anonymization and the fact that you're not uploading everything to the cloud. Now, what if you have on the right hand side, um, there are multiple clouds involved in a transaction with multiple apps on the same device? Think about it as like your bank application plus a royalty application that are running on the same device. So today, again, each one of these apps has a backend on the cloud that needs to, all the data from each app needs to go to the backend of each, and then from backend they need to communicate and do whatever needs to be done. With Mimic, now the two apps on the front end device can communicate directly, so we're enabling app to app communication right on the same device with no need to go to any of the backends. And by doing that, you obviously would have a much more secure, 100% private, and much cheaper solution, which works much faster and efficient as well. Then, when you're looking at another example, is the app modernization. That's again, banks were early adopters of computer technology. As a result, there are a lot of field-proven legacy applications that exist today, and a lot of financial institutions are looking to modernize some of the applications. And the way that's being done today is that since the legacy app has this monolith backend, they pretty much have to throw away 90% of that backend and redevelop everything from scratch, because the entire and remember, the entire intelligence is on the backend. So they have to dissect in that backend into pieces and then start developing it in microservice space. Now, what Mimic enables is that basically you encapsulate your backend and expose it through APIs to an API gateway on the front end application side. And then you establish a second tenant on any cloud of your choice, and you start adding those modern features to the front end application side, one microservice at a time, so one function at a time. And by doing that, you're avoiding the disruption of workflows. And over time, you can add new features through the front end. And you're also breaking the silos via interoperability. So basically, now by doing this, you're able to modernize your application without disruption. Each microservice now on the front end labels the data, anonymize it, and sends it to the appropriate database and destination wherever it needs to go. Not all the data, what needs to go. And you can do all of this without touching your old legacy backend system, which basically you end up achieving that modern application at a much cheaper cost, without interruption, and in a much faster time frame. There are, of course, many use cases when it comes to fintech and financial institutions. These are just some of the examples. Of course, we don't have time to get into details of these, but I'd be happy to discuss this later on a separate call. But things around data wallet, which is again privacy angle, will be addressed now using our solution. Micropayments, peer-to-peer transactions, things around hyper personalization, embedded finance. So there are many different use cases that now can be enabled using our platform with full data privacy in place. Um, so in summary, by architecting your application in microservice architecture end to end, you're avoiding moving unnecessary data to the cloud. And by doing that, you're lowering the carbon footprint and obviously the cost that is associated with that. You're enabling data privacy by function with military grade security. You're able to control the interoperability from front end, and that way you're breaking through the silos. And then you're simplifying your app modernization without disruption. That wraps up my quick overview. This is my contact information. Obviously, I'd be happy to set up call with you. Just reach out to me or through our partner Claysol, that we can get into more details. And but I'm here if you have any questions. I can quickly address that. If not, I can pass it on to my colleague Siavash Alamuti to go over his presentation. And at the end of this session will be available for Q&A as well. Thank you so much.